Okay, we're going to start the review going over ending behavior, zeros, maximums, and minimums. You're going to get your function and you're going to plug it into your Desmos calculator, as I've done here. And if you notice on this graph, it's going to infinity when x goes to negative infinity. It's also going to infinity when x goes to infinity. So my answer's here when we have a positive leading coefficient of an even degree. The ending behavior is to infinity for both of them. Okay. Then I go to my graph for my zeros. My zeros I'm going to actually get first, and that's at -2, -1, 1, and 3/2 or 1.5. You can plug in as a fraction or a decimal. So -2, -1, 1, and I'm going to write 3/2. My maximum, we only have one maximum, and it's important we scroll here and make it a little bit bigger so we can see the maximum point. We don't mix it up with a y-intercept. So that point is -0.062, 6.31, and I want to copy down that exact point. So -0.062, and then it's 6.031. Now with this type of problem, I'm going to have two minimums, and I need to write them both down. I come down here, my first minimum, -1.586. -1.586, and the y term that goes with that is going to be -3.872. -3.872. My second point will be right here, where the graph turns again, 1.273. 1.273. -0.922. -0.922. And that's what my first problem is going to look like. Okay. As I come down to my second one, I need to plug that graph into my Desmos calculator. So that's what we're going to do. You can get rid of the 2x to the fourth, and it ends up being a -x cubed plus 6x squared minus 3x, and then minus 4. Okay, and I want to move my graph to a point where I can see it a little more clearly. Okay, now this one, the negative leading coefficient, or the leading coefficient I should say, is negative. It's odd degree. So when you have a negative, when you're going to negative infinity on the x-axis, your negative leading coefficient, odd degree, you're going to positive infinity on the y-axis. As the x goes to infinity, the y goes to negative infinity. And if you go back to the graph, that's pretty clear. As the x is going to negative infinity, the graph is going up. As the x is going to infinity, the graph is going down. My zeros here are not going to be as neat as the previous ones. So -0.584. -0.584, I just need the x term of them. And then we have 1.294. 1.294. And then finally we're going to have 5.29. And those are my x's. With the x cubes, you're only going to have one max and one minimum. Okay? My minimum, got to make sure I'm not hitting a y-axis. It's the actual minimum. 0.628. So minimum 0.628. And the y-coordinate of that point, -4.392. -4.392. Right? For my maximums. Need to kind of shift the graph up a little bit so we can see it. It's right here. 3.732 for my x coordinate of it, and my y coordinate 16.392. And round to whatever the Desmos graph gives you. I apologize on this. I mixed up when I transferred it. 0.62 and 0.26. It should be 0.268. Sorry about that. All right, as I move to the next page, I'm going to plug this equation into my Desmos calculator. So this one is 3x squared plus 3x cubed plus 8x squared minus 2x minus a 7. All right. So in this case, as x goes to negative infinity, y goes to negative infinity. As x goes to infinity, y goes to infinity. So as we're going to the left of the graph is going down to negative infinity. And as the graph goes to the right, the y eventually goes up to infinity, which goes along with positive leading coefficient, odd degree. The y follows the x in that particular case. My zeros here are simply going to be negative 2.573, negative 1, and 0.907. So those are my zeros. Once again, I don't have to write them as points because we know the y coordinate is going to be 0 each time. So 0.907, negative 1, and then negative 2.573. Now my maximum, negative 1.895. Is the x coordinate of it. The y coordinate would be 5.103. Now we're going to the minimum. So now my graph turning back up. Once again, don't mix it up with the y-intercept. 0.117 and negative 712. 0.117 and negative 7.12 is my minimum. And once again, we're just writing that off of the graph. Our last graph, we have negative 2x to the fourth plus, it's an x cubed, minus 8x squared minus x plus 6. Now this one doesn't have as much bounce as it possibly could. That does happen. Sometimes it just works out that way where you don't have as many real zeros. Okay, so this one though, once again, when you have an even degree and a negative leading coefficient, that means your graph is going to open downward in both directions. When there's a positive leading coefficient, we want both to infinity. In this case, we're both going to negative infinity. Since this particular graph only has two real zeros, and that can happen, we have negative 0.819 and 0.786. So negative 0.819 and 0.786. In this case, there's no minimum. Okay? And there's really only one maximum. And that maximum is negative 0.0617. Negative 0.0617. And 6.031. And if there is no minimum, we can write really the minimum is negative infinity, okay? But since there's no turn in the graph, we'll leave it as none right here.